Okay, so this is the Colecovision that's not currently working. Now, as you can see from the picture that I should have up on the screen right now, you will see that there is some dots. Okay, so these dots, and you can see they're in a pattern. Now, what that suggests is that there is something wrong with either the RAM or the video RAM. Now, being that it's a ColecoVision, I don't think it has very much RAM. I've not actually checked, to be honest, so that's one to check. But what it does have is this 16K of video RAM here. So let me just move this to the side. Did you see that? Bug just flew past. Okay, so now to test the RAM, what I'm doing is I'm grounding the output of the RAM of each chip to see which one is affected by grounding or affects where the dots are on the screen. So it's probably not the best method of trying to fault find, but it is definitely the easiest. It's basically turning each of the chips off individually until you find out which one's faulty. Now, the reason for the faults on this chip is the RAM requires three types of input voltage to run. It needs a +5, a -5, and a +12. Now, the ColecoVision power switches have a known fault where sometimes one of the voltages doesn't get through, and if the chip is missing any of those three voltages when it fully powers on, it actually damages the chips. Very, very bad design. So what I have as a replacement is, let's see if the camera can see this, if I can move it around, down, there we go. Okay, is some replacement chips. These are pin replacement chips, almost. So where it has the -5 and the +12, it actually removes them and gives a couple more address lines. So instead of being 16 kilobits, they're actually 64 kilobits each. So they're not a direct replacement, but that's good, because what that means is that you when you replace it, you're replacing it with chips that only require 5 volts rather than the +12 and the -5 as well. So they won't get damaged by there being a voltage problem. So therefore, it lasts longer. But I'll just show you what happens when I ground the chip. That's probably best I quickly look up the pin out, isn't it? So I know which one I'm doing. There you go, it's number 14. So all I do is I stick a cable. Let's get the picture back up so I can see it. Right, I get the ground, which is just, I'll just grab it off the power supply here. Get the ground and put it onto pin 14 of the chip that I know is faulty. And you see, it's vanished. Well, it's making it go away. Do you see? If I get rid of that, and then there it is back again, gone and back. And I think that's definitely part of that chip is faulty. So what I'm going to do is remove everything that particular chip does, because if I do it to the other ones, you don't get that same thing. You see, it just affects the letters, doesn't actually affect the entire display. But this one chip, you can see when I do it, if it's going to get on there, it affects the entire display. You see, so that would suggest that maybe that particular chip is naffed. So what I'm going to do is I'm going to pull that chip out. Well, I'm going to pull all 8 chips out. Let's just do the whole lot. So pull all 8 chips out, replace them with the 5-volt equivalents, and let's see. So I'll get on and do that, and we'll show you the results in a minute. Right. So the chips are not, well, they are pin replacement, but the voltages aren't. So there's a little bit of preparation that you need to do, and that is basically pin number 8 there. You bend round to pin number 9, and pin number 1 you cut off because that's not actually connected. So pin number 1 is not connected. Pin number 8 is what normally would go to the 12-volt line, where you don't want it going into 12 volts. Now, you don't break it off because it's actually the 5-volt line now. So you bend it round, and then pin number 9 on the other side, the part of pin number 1 that you broke off, you then solder to then be able to put it into the middle. You then solder to be able to then jumper that across to the other pin and get your 5 volts across, because you still need power going to pin. I'm trying to get this lined up. It's very difficult. Maybe I should put it down. But yeah, you still need power going to pin number 9, because pin number 9 is address line 7. So you can't just leave it floating, because it could be on or off. So you have to make sure it's got a voltage. So ideally it's connected to the 5 volt line, so it makes it on, and then you just tap off of it with your extra bit of cable, or extra bit of pin. That's it. So I'll prepare that, and then we'll plug it in. We'll test that one, and then we'll do the same for the other 7. Okay, so here's the chip back on the board. It's this one here, and just there, that's the bridge that I've made between the address pin and the power line for the 5 volts. And then up here on pin 1, I've actually just chopped that off and disconnected it. I'm sorry about my camera. This is a 1080p camera, and it is rubbish. So it's a Creative in-person HD, and if I turn the light on, everything vanishes or turns sort of cartoony, and if I turn the light off, it's sort of the right colours, but everything's just incredibly pixelated. So anyway, as you can see on the screen, it's playing nicely. So what I'm going to do now is just go through and replace all the rest of the chips. Okay, so that's all of the rest of the chips ready, prepared, ready to be soldered in. So pin 1 has been cut off on each chip, just about there. You can see it's been chopped off. That's actually a better view, isn't it? So yeah, so pin 1's been chopped off on each one. Pin 8 has been bent round and then soldered on to pin 9, you see. And what that's doing is it's pulling pin 8 high, which is address line 7 of the 64K of RAM. So all I need to do now is solder these onto the board, and that will hopefully negate the need. Well, that does. It removes the need for the -5 and the 12 plus on the video RAM. So we won't have that issue again of the power supply failing on one of the power lines and blowing the chips. And let's see if we can move this across. Is it going to move? What is wrong with my camera? Look at this. How many frames a second is that? It's awful. And so that's the first one in, and then the rest I've got to do now, and that's it. Okay, and there's all the chips out. Took about 2 hours to get past all the soldering and get it cleaned and everything, so now we can put the new ones in. And there you go, that's all the chips in, soldered in, and I can't believe it actually worked first time. No joints broken or anything, it was just perfect first time. So last bits to do then is put in a couple of sockets on the back, you know, AV sockets for this bit here is the better turn it off if I'm moving things around. This little thing here is the composite amplifier that I made that just taps straight into one of the chips there. So hook up a connector for that, hook up a connector for the audio, clean the joystick thing, this controller, if I can find the camera, there it is, clean the controller, because it doesn't quite work. You have to push it very hard, and I think it's probably just dirty joints. And then the power supply. So the power supply is where are we? Here. So that's the power supply. Now this is what I made. It's a bit too much. This thing here is a 35 or 30 VA, 15 to 15, so 30 volts AC across, which is then going into here where you've got there's a 12 volt regulator there and a 5 volt there, and a -5 volt around there. Hopefully it will be a case of I don't need the 12 anymore, but I have to look at the schematics to find that out. Not the end of the world if I do, but what I'm going to do is this is just too much. it's just too much power, and trying to get 30 volts down to 5 volts, the regulators are just getting ridiculously hot. So what I'm going to do is use an old Xbox 360 power supply, which already has 5 volt and 12 volt in there through a it's not a regulator, it's a, oh god, I forget the name of the type, but basically it just does bursts of power to that switching power supply. That's it. So switching power supply, which means much more efficient, less heat. And then I have another chip. Let's see if we can get this in the camera. There it is. There, another chip there, and all that does is it takes the 5 volts and inverts it. This is an inverter, a voltage inverter, so that will give me my minus 5 volts, which the 360 power supply doesn't currently have. And that's it, and then put it all back together, and job done. Okay, so it didn't actually need the 12 volts. Well, sorry, it didn't need the minus 5 volts, because it was only for the video RAM that it needed the minus 5 volts. So the plus 5 is for the normal TTL logic that's all around the board, and then the 12 volts is for the composite video signal amplifier, which is not this. This runs on 5 volts. The little bit of an amp I made, but the actual chips around this area do require 12 volts. So unfortunately, it has to stay. Now, what I've got here is, so the only wire that's now connected is the 12 volts in the ground coming in, and just like in a Mega Drive, or Mega Drive 1 anyway, I've connected the 12 volts to I've screwed it down after I unscrew it. I've connected the 12 volts to a voltage regulator, 7805, which is, you know, what you would normally do with a voltage coming in which is higher than 5 volts. So with a Mega Drive it's 9 volts. And then I've strapped it to this heatsink. So I've just got the voltage regulator on there, and a couple of capacitors, and strapped it to the heatsink, and I get my 5 volts, no problem. And the system turns on. Brilliant. Brilliant. Except the heatsink, because it's doing that drop from 12 volts to 5 volts, the 7 volt drop, I think at the I think it's ridiculous, like I think it's rated at 2 amps, at least this 5 volt board, which is a lot. But I think that may also include the peripheral on the front there. So just say it's an amp. So an amp at 7 volts, I believe, equals 7 watts. Now, if you get one of those cheap soldering irons from Maplin's or wherever, that 7 watts, you can get soldering irons at 10 watts, 15 watts. So, you know, it's a lot of heat, even though it doesn't sound a lot. Anyway, you couldn't touch it. It was so hot, I could not touch this. It was like, ow, that's actually really, really hot. So, so I'm not going to be using a voltage regulator, because I just don't feel it's not fit for purpose. And that's probably why the original power supply was caked in that block of plastic, is because of the amount of heat that the thing gave off. So anyway, that's old technology. Now, new technology, we do things like this, which is this little chip here. It's tiny little 8-pin IC there. I put a few capacitors on, so there's a capacitor there. I put on this rather large resistor, but it's 0.33 ohms, but it's very high wattage. Anyway, a few other little components, get it all together, and what it will do is it will turn that 12 volts into 5 volts. And what this chip does is it's actually a switching power supply. So unlike the regulator, where it's using resistance to drop the power, which is then creating heat, what the switching power supply does is it does the voltage in bursts. So like with an electric heater, where the heating element isn't on all the time, it comes and goes in bursts until it gets to a good temperature, and it just regulates at that temperature, so that it's more energy efficient than just leaving the element on all the time. Well, exactly the same with these chips. The electric comes in bursts, but very, very quickly. You know, you're talking kilohertz, and what happens is that it charges a capacitor, and well, it goes through a coil, It doesn't look like a coil, but it is. This is a little coil here. It goes through a coil and a capacitor, and it keeps the charge. So as it bursts enough to charge the capacitor to 5 volts, and well, should be around about 5 volts. I'm not entirely sure what the bursts are at. And then it keeps, as the capacitor starts to discharge, it then bursts it again. But it does it so quickly that you get no ripple, hopefully. So anyway, I'm going to quickly solder one of these together and create a 12 volt to 5 volt switching power supply. And effectively, what that should do is incredibly efficient and no heat, which means this thing will run cold. We will see. Okay, here's a little tip for you. Always read the circuit diagram. The bloody instructions from the manufacturer's website. This huge capacitor here is a 470 microfarad capacitor, and it should be picofarad, not microfarad. So I was watching it on the oscilloscope, and the waveform, it was going up and down, but it was going up and down ever so slowly. It was about every, say, 30 seconds, rather than, you know, thousandth of a second. So yeah, picofarad is more this side. There's about 100. More this side. There's about 100 in this little bag in comparison to this giant one here. So oh well, no biggie. Swap it out. And for those of you who are interested, that's the difference between picofarad and microfarad. The giant bulbous one there is a microfarad capacitor, and this tiny little thing here is a picofarad, and you need glasses to read the symbols on it. Well, it's in there, and there it is. You can just about see it there. Well, what can I say? It does exactly what it should do. It outputs 5 volts, exactly how I wanted it to. The only problem is that when I turned it on, one of the little wires started to smoke a bit, and so I've put in, right, so that's like the coil of wire. So I put in this thing, which is like a much bigger coil of wire that can take a lot more current, and it turns on now. The only problem is that it drops from 5 volts to about 4.2 volts. So the picture is all crappy because there's not enough voltage. And I think the voltage drop is just purely down to the current being drawn. This Colecovision just draws so much power. It's unbelievable. So the next thing to do is get one of these things here. There you go. A power MOSFET, and then hook on a heatsink like that, and then strap that to the output of the power supply, and what it will do is the switching regulator will regulate the MOSFET voltage. So exactly the same as it's doing internally, turning it on and off, but this has got a much higher current. I mean, this thing will switch 30 amps, so more than this thing could ever draw. So yeah, that's the next stage then, is to get that on there. Okay, so here is the Colecovision finished. What we have here, I'll zoom out by lifting the camera up. This is the power supply. So that little thing down there, that is the switch mode power supply for the 5 volts. So 12 volts is coming in, and this is switching it down to 5 volts. And then this here is a -5 volt, a DC to DC converter, because on the front of the Colecovision, just here, there is a adapter thing, you know, like a port for plugging in extra peripherals, one of them being an Atari 2600 adapter, and I think it requires -5 volts, so anyway, I've put that in there anyway, just to be sure. And then over here, this is, I can get the camera to point in the right direction. This here is the AV mod, so this gives you composite video and audio, which is just an old Xbox adapter. So to show you the other end, which is just these normal things. There you go. And that's it. So the RAM, obviously, was the thing that was actually wrong with it. If we can find it, there it is. So all of those 8 RAM chips there, they are actually 64K chips, but are now 16K chips because they've had the modification. So they are a pin replacement, apart from having to bend and cut the pins for the ColecoVision memory. But that's it. So we've got ourselves a working ColecoVision. Okay, so there's the 360 power supply, which I'm only tapping off the 12 volts. Is going into the back of the ColecoVision, and then the ColecoVision has now a AV cable coming out the back, which then goes up into the TV, and there's the screen just about coming into life. You can't capture it very well with a camera, but there it is, doing the Donkey Kong with perfect picture and sound.